Good morning to all. Myself, Mr. T.M. Devakar, working as the assistant professor in ENTC department in Sharada Institute of Technology, College of Engineering. So, in the previous video, we studied about the various parameters related to electrical network. So, today we are going to study the classification of electrical network. This is also very important in this classification. We are going to study the different networks. So the behavior of the entire network is totally depends upon the behavior of the circuit elements and its characteristics. So based on such characteristics, electrical network can be classified into 10 different types. So once again I'm telling you what is circuit elements. Circuit elements means resistors, capacitors, inductors. These are the circuit elements. So the behavior and characteristics of that resistors, capacitors and inductors distributes the classification of the electrical network. So let us see one by one. The first, linear network. So as it name itself, it is saying what is linear network. A network whose elements, so like resistor, capacitor and inductors, are always constant irrespective of the change in time or change in voltage or change in temperature, is known as a linear network. So the parameters resistors, capacitors and inductors, they always remains constant if we change the time, if we change the voltage, if we change the temperature of that circuit, it should remains constant. So this is called as a linear network, and the Ohm's law can be applied such kind of networks only. This is very important, Ohm's law. We are going to see what is Ohm's law in this lecture. Next one is a non-linear network. A network whose circuit elements or whose circuit parameters, they always change their values with change in temperature or change in time or change in voltage, is known as a non-linear network. It is exactly opposite of a linear network. As in a linear network, we are actually we are seeing resistor, capacitor, inductors, they cannot change their values. But in non-linear network, the values, the circuit elements like resistor, capacitor and inductors, they change their values according to the change in temperature, voltage. Suppose means if we change the voltage, the values of the resistors, capacitor, they can also be changed. So such kind of networks is called as a non-linear networks, and Ohm's law is not applicable for such kind of networks. Next one is a bilateral networks. A circuit whose characteristics behavior is same irrespective of the direction of current through the various elements. So in a given network, the flow of current is always changing. So the behavior of characteristics of that element is always same if we change the direction of the current. Means in a circuit, the direction of current, if the direction of the current is changed, the characteristics behavior of that circuit, it is remains constant. It's called as a bilateral network. Means the good example is the circuit consisting only the resistances is the best example of bilateral network, because if the circuit consists only the resistances and if we change the direction of the current, so the characteristics behavior of that circuit, it is always remains constant. Next one is the fourth one is a unilateral network. A circuit whose operation or whose behavior is dependent on the direction of the current through the various elements is called as a unilateral network. So it is exactly opposite of the bilateral network. So if the direction of the current is changed, the behavior and operation of that circuit will get changed, and it is changing according to the change of directions. So that's why it is called as a unilateral network. So for example, a circuit consisting of diode, because as we know that the direction is will allow the flow of current in only one directions. If we change the direction of the diode, or if we change the position of the diode, so the direction of current will get changed, and because of this the behavior of the entire network will get changed. So that's why the behavior of network depends on the direction of current is called as a unilateral network. The next one is active element. A circuit which contains at least one source of energy. So what is the source of energy? So there are two source of energies: voltage energy source and current energy sources. So if a network or if a circuit which contains at least voltage source or energy current source is called as a active network, because active means it provides the voltage or current to the circuit elements. So for example, the transistors, op amps, batteries, signal generators are also the example of the active elements. So next one is a passive network. So it is also exactly opposite of the active network. So already we know that what are the active elements. So once again I'm explaining what is the passive elements. So capacitor, inductor, resistors, these are the passive elements. So the definition of passive network is a circuit which contains no energy sources is called as a passive network. So the network consists of passive elements, as I told you now: resistance, capacitors and inductors, as well as thermistors. These are the passive elements. So next one is the DC network, direct current network. A network consisting of DC sources. Again, the sources are also two types: AC source and DC source. DC is a direct source, direct current. AC is a alternating current. So what is the definition of the DC network? A network consisting of DC sources which are fixed polarity sources, not varying with time, is called as a DC source. So the sources having the fixed polarity, they cannot be changed and they should not be vary with respect to the time, is called as a DC source. Next one is a AC network. A network consisting of AC sources which are alternating sources and which is periodically varying with respect to the time is called as a AC network. The next network is a lumped network, a network in which all network elements are physically separable is known as lumped network. Most of the circuit elements are lumped in nature. So every element of such network is shown to be concentrated at distinct point in a network and is identified as a particular parameter of the network. So you will get this clear concept during the example. So only we just know the circuit or the network in which all network elements are physically separable. That's what is known as a lumped network. So next one is a distributed network. So what is distributed? It is exactly opposite of lumped network. So network whose circuit elements or network elements like resistors, inductors, and they cannot be physically separable for analysis purpose is called as a distributed network. So best example is a transmission line. So in that transmission line, here you will come to know what exactly the physically separable. So in the transmission line, the resistance, capacitor and inductors are distributed along its lengths and they cannot be shown as a separate element anywhere in the circuits. So this is called as a physically separable or physically not separable. So next one is a very important laws we are going to study, and this is the basic law as you already studied in diploma as well as 12th standard. So this is the Ohm's law, because the network analysis is totally, or this is the main law on which the network analysis is totally dependent. So what exactly the Ohm's law? The current flowing through the electrical circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit. But the temperature should remains constant. So this is the statement of the Ohm's law. Means what it is saying, current which is flowing in the circuit is always proportional to the voltage and inversely proportional to the resistance of that circuit. So in mathematically it is given as I proportional to the V upon R. So I is the current flowing which is measured in ampere. V is the voltage applied. R is the resistance of that inductor. So this is the formula of Ohm's law. I is equals to V upon R in ampere. V is equals to I into R, that is in volts, and V upon I is equals to R in ohms. So these are the three important formulas you always remember. So next one is a Kirchhoff's voltage law. In short form, it is a KVL law. That is a Kirchhoff's voltage law. It is very important law in network analysis. Let us see what is the statement of the Kirchhoff's voltage law. So The algebraic sum of all branch voltages around any closed path in a circuit is always 0 at all instant of time. So once again I am repeating here what is the statement or what it states. The algebraic sum of all branch voltages around any closed path in a circuit is always 0 at all instant of time. So this is the network, or this is the circuit. The algebraic sum of all branch voltage means AB is a branch, CD is another branch, EF is another branch. So the voltage across these branches, that is the voltage V1, voltage V2 and voltage V3, these are the voltages across branches AB, CD and EF. So the algebraic sum of V1, V2 and V3 in a closed circuit path, so this is a closed circuit path, is always equals to 0 at all instant of time. So in other words, you can also say it as Vs is a total voltage source, and V1, V2 and V3, these are the internal branch voltages. So in other words, you can also say it as Vs is equals to V1 plus V2 plus V3, because the current provided from this voltage source. So I is a current flowing through the circuit, the same current flowing through the V1, V2 and V3. So there is no different currents are flowing in these branches. So current is same. The current through AB is also I, current through CD is also I, and current through EF is also I. So when the current passes through the resistors, there is some loss of energy, and therefore there is a voltage drop. So any element, the current always flows from higher potential to the lower potential, means the current always flowing from positive to the negative. So the direction of current is always given, it is like this. Always means the current flowing from starts from positive of the battery and it should be come to the negative of the battery. So it is considered as a closed path. In the previous lecture, in the previous slides, actually we studied what is Ohm's law. So here we find the voltage across each resistors by using the Ohm's law. So what is Ohm's law? V is equals to IR. This is the formula of the voltage, Ohm's law. So if we find what is the voltage across branch AB, so phi R1 is equals to I into R1. Phi is a voltage, R1 is a branch, R1 is a resistor. So I is the same current flowing through the branch AB. So VR1 is equals to IR1. Like this, if you find the voltage across branch CD, phi R2 is equals to IR2, and the branch EF across this, phi R3 is equals to IR3. So what Ohm's law is saying, the algebraic sum of all branch voltages. So V1, V2 and V3, these are the branch voltages. So the algebraic sum of all these branches are V1 plus V2 plus V3, and it is always equals to the total voltage Vs. So Vs is equals to V1 plus V2 plus V3. So finally, by applying KVL, we can find out the Vs is equals to Vr1 plus Vr2 plus Vr3, or V is equals to IR1 plus IR2 plus IR3. So let us see one example. So for the circuit shown in figure, determine the unknown voltage drop V1. So V1, this is the V1 is the unknown branch, unknown voltage drop. So we need to find out what is the branch voltage. So 30 volt is a total voltage source, 2 volt is a voltage drop across this branch, 1 volt is another voltage drop, 5 volt is another voltage branch, 3 volt is another branch. So according to the KVL's law, what KVL's law is saying, the algebraic sum of all voltages is always equals to the total voltage. So 30 is a total voltage source, so is equals to the 2 volt plus 1 volt. So V1 is the unknown voltage drop, we need to find out, plus 3 volt here plus 5 volt here. So 30 is equals to V1 plus 11, because the sum of 2 plus 3, 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 5 is 11. So V1 is equals to 30 minus 11, therefore V1 is equals to 19 volt. So this is the best example to understand what is KVL law. So thank you. In the next we will study more and more example to understand the KVL laws. Thank you.